In this video, we want to learn about the statistical inference when we have more than one sample. It's like that. The first step is that we want to learn about the how can we find out. It's a review almost. So how can we find out the difference between two means? Like we have more than one sample, or we have more than one population. So we have X bar 1 and X bar 2. And then when we say statistical inference, it's like that. We want to know that what's going to be the confidence interval, or what's going to be the hypothesis testing for them. So it's very similar, right? So if you know the confidence interval, you can go with the hypothesis testing after that, because you just need to know the test statistic, and you can derive your test statistic from the confidence interval. Or if you know the hypothesis test, you can play with it, and then you can find out the confidence interval equation from it. The starting point is different. So here we are interested in that we have like two means, mu1 and mu2, and we would say that X bar 1 minus X bar 2, what's going to be the difference between them? The first step is that we want to draw, like, we want to know that what type of distribution that we have. Let's say if originally we assume that they had a normal distribution, so the X bar 1 minus X bar 2, they would have it's going to have a normal distribution as well. But after this, you remember that when we had one sample, we would say that we know the variance, or we don't know the variance, so we developed like two cases. So here is going to be two cases as well. So it's like that. Let's say case 1, the sigma 1, 2, and sigma 2, 2, they are known. Okay, in reality, we never use this because it's like that. It rarely happens that we have the two populations and we know both of the sigma 1 and sigma 2 for them. But let's say if it happens, so it's going to be very simple, like again Z table, the same. When we had one sample, it was Z table as well, right? Over there we had like sigma 1, like the standard error for X bar, it was sigma power 2 divided by n, but the square root of it, we were looking for the standard error, like the variance was sigma 1 power 2 over n. So you get the root square of it. But when we have like two samples, we just add the variances, and then we would get root square of it. So it's going to be like, here is the confidence interval, X bar 1 minus X bar 2 plus minus Z times this. So this one is a standard error. It means that, so when you see this, don't tell me that, Lana, we don't know what's the test statistic for it. So from this equation, you can find the test statistic. So here, for example, this is a test statistic. In case 1, we said that it's X bar minus mu divided by the standard error, right? So instead of X bar here, you would have X bar 1 minus X bar 2 minus, and instead of mu, you would have mu1 minus mu2, like in parentheses, divided by the standard error. You're going to write down this, like the square root of the sigma 1 power 2 over n1 plus sigma 2 power 2 over n2. So this is your standard error. This is for the case 1. For case 2 here, it's a little different. And when we had one sample, we just said that, okay, let's use the T table. It was easy. We had one sample. We didn't know the sigma of the population, so we would go with the T table. But here, we don't know the sigma of the population, but we can have two different situations. The first part is that, okay, we don't know the sigma of the population, but we know that the sigma of the, for the first case and this first population and the second population, their sigmas are close. So in that case, or they are equal, we have one situation. The second situation is that we don't know the sigmas of the two different samples or two different populations that we have, but we know that they're unequal. So in that, we have different situations, like as you saw. For the first one, is like you would say X bar 1 minus X bar 2, T, and then half of the alpha, and then nu is the degree of freedom, right? And we have for degree of freedom, we would say N1 plus N2 minus 2. It's like that, N1 minus 2 plus N2 minus 2. And then we would multiply it by SP. SP is like pooled estimate that we would use. And for the pooled estimate, this is the equation that we have. In fact, the degree of freedom of each of these samples or the populations that you would have, like the sample of the population that you have, times by the variance of the specific one, right? So it's the degree of freedom of N1 times S1 power 2, like the variance of S1, and then N2 minus 1 S2 power 2, like the variance of the second one, and then you would divide it by the degree of freedom of the total as well. So this can be SP, and then we would multiply it by the square root of 1 over N1 plus 1 over N2. So that's the for the time that we don't know, we are in case 2, we don't know the variance, but we know that they're equal. And then we can have a situation that they're unequal. When they're unequal, it's a little different. We would write down like the T, we would still, we are working with the T table, the same thing that we had when we had like one sample or one population. And then we would say T half of the alpha, and nu for the degree of freedom. This is the equation that we would have. It's a little like different, but if you look at it, in fact, it's like the variance of the first sample plus variance of the second sample power 2 divided by the variance of the first sample power 2 times 1 over like degree of freedom of the first sample plus variance of the second sample power 2 times 1 over degree of freedom of the second sample. But you don't need to memorize it like the way that I said. So you can have this equation while you are working with the while you're going to work with these stats questions related to this one, or on your exams or later. We always have these equations available. So that's for case 1 and case 2. And for these nu, remember that this one, you don't need to round it up because it's N1 plus N2, all of them are integer. But for this one, even if you find out 18.1 rounded up, it should be integer because you want to read it from the table, right? So nu is degree of freedom. So round it up by convention to the nearest integer, but you will round it up all the time. So you can go and look at the tutorial or practice problem of the chapter 1, example 5, and comparing two means. The next video is going to be about when we have the when we want to compare the sigmas, like their variances, because we said that they are not case 2 was the time that we didn't know the variance and they were equal or unequal. So how can you decide that if they are equal or unequal? So in the next videos, I'm going to talk about it, that how can we say that if sigma 1 and sigma 2 are equal or not. In fact, this is the reason that we define case 3, because this is the case 3. So we're going to talk about case 3 of the when we are working with the hypothesis test and the confidence interval.